lecture is we're going to talk about Move from a security perspective. And I've mentioned Move a couple times today, and I know it's exciting, and let's dive in. So this is the syllabus. First, what is Move? And then we're going to talk about some important concepts. And then we're going to start with a simple tutorial. You can have some hands-on experience to develop some simple Move coins. And then we're going to talk about the ways to interact with the contracts on the blockchain, modules and scripts. And then we will talk about like blockchains based on Move. And sixth, we'll talk about standard library. So what is Move? Move is a secure, sandbox, and formally verified next-generation programming language whose first use case was the Diem blockchain, then called Libra. This project was halted by SEC, but was developed by Facebook team. The engineers left the team and started building different blockchains based on Move. Move is a smart contract language made for manipulating digital assets and was originally designed with security in mind. Here is the basic structure of a Move package. When you use Move new and the project name, here's the content of the Move package. Move.toml is required. It basically has some dependencies and some intros about the package. And sources directory is also required. It stores the source code. And script directory is optional. You can put script file inside the source if you want. And example file is also optional. It's frequently used in test and dev mode. The templates is optional. And the test is obviously optional because we only use in test mode. Yeah.
So if this is founded on the basis of Libra and it's been stopped, right? Does it mean that it's not going forward or it's been deprecated?
So Move was developed by Facebook team. It's called Diem, and Diem is still, the repo is still on the GitHub. I believe it's archived. So the Move was built forked from the Diem and started taking a life on its own, and start a lot of people was attracted by this project, and people start contributing on it. So it's still like a open source project.
Right.
Yeah, almost like a Bitcoin core, I'd say.
Right.
Yeah. Some important concepts. So first we have struct. Let's take a look at the struct. It bears some similarities to the struct in Solidity, and it is the only way to create custom type in Move. Remember, references and tuples cannot be stored as a field value of structs, and unlike Solidity, recursive structs is also not allowed in structs. So why they are not allowed? Because Move is a formally verified language, and the bytecode verifier needs the input to be all serializable. But if you have a field of tuples or references, they are not serializable, and the Move bytecode verifier will not be able to function. And here we can just get familiar with the shape of struct. So we have the struct, and then we have the name of struct, and then the keyword has is very important. It indicates what capabilities this struct has. The first struct has the capability key, and the second has the capability drop and store. We will discuss capabilities later on. And yeah, the struct can store different types of variables. Now, here's the capability. There are 4 types of capabilities: copy, drop, store, and key. This is the same code snippet from the last slide. First, key. What is key capability? Key makes an object able to be stored on-chain. And if an object does not have key, it has to be stored under another object or destroyed before the contract finishes execution. This is very different from Solidity. Key is a brand new concept in move. And store stores an object to be stored under another object. You can think structs as boxes. And store allows this particular box to fit inside other box. Drop allows an object to be quietly destroyed. Simply allowing the object to go out of scope will destroy it. And we have the last one is copy. It's not put in here because the copy is widely used, but in this example, it's not shown. Copy allows an object to be copied. Non-copyable objects can't be copied. And this ensures the authenticity of assets. You cannot just copy assets in move. But in Solidity, you can just add numbers to your balance mapping that will basically create infinite amount of assets. But in move, it fits into our concept of asset, which is valuable and cannot be copied just out of will. A resource is another important concept in move. Resources are structures that only have two capabilities, key and store. Resource must be stored under the account. One account can hold one resource at a time. And there's no dangling reference to global storage. For example, let's look at this code. Struct R has key, and it has the value of UN64. And if you're trying to borrow global, which is a operator in move, it will error out because you cannot just borrow this reference, and it has a dangling reference to global storage. The second part will also not compile. Any questions? Which part?
So why it cannot be borrowed?
You mean this first one or second one?
We start from the first one.
Okay. So this function return direct resource reference bad takes in the address and returns its reference. But when you try to borrow this global, it's a dangling reference to our global storage. And move does not allow resource reference to be dangling around.
So which one is being borrowed? Which resource?
We're trying to borrow the struct R.
Okay. So R is being borrowed.
Yeah. And same, like the struct R, we cannot access the field F. At the end of function, you have to make sure that the reference gets either gets processed properly, not just have a dangling reference at the end. So just like other programming languages, move can have different programming bugs. So here's a small quiz. Please spend 5 minutes, look at this code, and try to find what bugs are there. It's a very basic program, and it just uses some basic concepts in and data types. There's no business logic in it. Just trying to prove that move also have bugs. So what potential bugs are there in this code? Any answers?
Current length cannot be zero.
Current length what?
Cannot be zero.
Cannot be zero. You mean it can or can't?
Cannot.
So if current length is zero, it will return. You mean that? Yeah, but this is a function pop. This is not the full picture of code. The pop function just trying to remove an element from this buffer. So basically, it has to be a length that's bigger than zero.
Maybe buffer does not contain value.
Sorry?
Maybe value is not in buffer.
Value is not in buffer.
Yeah, because I see that it contains a statement. So maybe it's
Yeah.
there. So the element position maybe not defined.
Yeah. If it's not in buffer, then the element position would be, this element position will not return. So it's the pop function will just not continue.
Sorry, I have a question.
Yeah.
So I see it says store and drop in the second segment, public
Yeah.
function.
Yeah.
So does it mean all those attributes there after the drop no longer exist, meaning they've been dropped? Which means that element position contains r buffer comma value. That one is nullified because the attribute no longer exists, and then the last statement also doesn't exist because it's all been dropped.
You mean this one, store plus drop?
Yeah. So after drop r buffer,
Yeah.
down buffer,
Yeah.
arrow t value t.
Yeah.
Then does that mean that the last two statements of code no longer exist because all those attributes are dropped? So the
At,
buffer comma value below is no longer
oh,
functioning.
I see what you mean. So store and drop is actually capabilities. That means the resource have the power to be dropped, to be destroyed.
Yeah.
This pop t means taking a type of has a store and drop, and we are taking this type run buffer. So basically, it means this buffer can be destroyed at the end. And it's not necessarily has to be destroyed, but it can be destroyed. But think of not move specific, but other bugs that can happen in other common programming languages. So this is just a bad implementation of buffer. So it's same for C++ or JavaScript. Yeah, I'm just gonna say it because yeah.
Struct doesn't have the drop capability.
Struct?
It has all capability.
Oh, it has drop.
But the one behind it.
Yeah, but in this function pop, we're not trying to destroy this buffer. We're just trying to pop an element from this buffer. So in this struct, there's an element called entries. Entries usually reference to which element it is in, or which element, how many elements are there. But in this pop, the entries are not decreased. So it would cause confusion in other functions trying to access this struct and think that it has this many elements, but in fact it didn't have. And another one is in a struct there can be in a vector there can be many values with the same value. So for example, it can have like 3 ones or 5 twos, but when you do pop, it only pop the first value it finds. So when developers think they popped all the elements that they're trying to remove, it actually only removed the first element that finds. So that's another potential bug. It's just a bad implementation of buffer. So in Move, bad coding also results in bugs, same as other languages. And it's very basic, so other programming languages have the same problem too.
Sorry, so pop means it will only populate the first attribute,
Yes.
right?
Yeah. Yeah. So let's get into a tutorial. We're gonna publish something similar to ERC20 in Solidity, but in Move. So we're gonna do a simple coin. And you can download the code from the pastebin, and we will create a project together. And in the meantime, if you can install Aptos CLI, it would be awesome. And in our sample coin contract, there's initialize, there's minting, there's burning, and registering, transferring function. So some novel concept, registering. In Solidity, you can just transfer assets to another address without the permission of that party, because it's just balances within this coin contract. It has nothing to do with the target contract, or the target address. But in Aptos, the receiver has to register first before they can receive this new coin, this new custom coin. So in order for the address to store this resource, it has to register first. And other functions are other 4 functions are the same for Solidity contracts. Demos. Okay. So I'm in the demo directory, and I'll create a new project to publish a simple coin. First, I run Aptos, move. First, I create a directory called new coin. And then I initiate the module. I think that's the name. And this will create a move modules folder, as we've seen before. So it contains a move.toml and sources directory. If you want to do scripts and tests, you have to create your own directory. And we have to edit this move.toml first before we can publish them. When you initiate your Aptos CLI, you have created a new Aptos address, and you can get them from the Aptos directory. So this is my Aptos config file, and I'll use the deployer account. You can set up different profiles for interacting with different move modules. And because I used default before, so this time I'm using deployer. The third parameter, account, is the account address. And in my new module, new coin, it just contains the package introduction. So it says the name is new coin, and the dependency is has a GitHub repo, and it will pull the Aptos framework from the GitHub repo. But in Move, every single package is published under the account. So we will set up our address here. So we'll add a new section called addresses and put sender as our account address. So this sender is same as my deployer address. And this name doesn't have to be sender, but in our source, the default address is defined as sender. So just go into this paste bin and copy paste the code. Yeah, so as we can see here, the owner address is actually called sender, and that's why I define sender to be my address. So on the source directory, I will create a new file called newcoin.move, and I'll paste in my code. I'll change the name to new coin. So far, I've modified the move.toml and added the source file to the sources directory. And now I can compile this contract. It takes a while because it needs to download the Aptos framework from GitHub. So as we can see, it is compiled successfully. The 9EA is my own address, and the new coin is a module that will be deployed under my address. So my address has 0 balance, so I need to get some test coin first before I can deploy. And this is a command I will run to get some test coin balance to my account. And my profile is deployer, so I'll change the account to deployer. This will invoke the faucet URL and get some test coin to the target account. So as you can see, I got 3 Aptos to my account. And I need that to deploy my contract. It's used for gas fees. And then I will publish my contract. Module address does not match sender. Okay, so here's I got this wrong because I need to put my profile under on the deployer. This uses my default account. Yeah, then I will submit my transaction to publish my module. As you can see, the transaction is successful. Let's view that in the Blockchain Explorer. Let's open up 2 Explorer just in case. And recall that we use the full node DevNet, so we need to switch our network to DevNet to see our transaction. So I'm currently in DevNet. I put in the transaction, it's there. And the sender is my address. This one is in mainnet, so definite. So this is my address, and I just published a module under my account. So if I click the modules, I can see a new module named new coin. And when I click show more, I can see the bytecode, that's the compiled version of move contract, and the ABIs, which is the interface to interact with it. There's a website that you can interact with it in a GUI, in a graphic user interface. The website's name is aptos/module/explore.vercel.app. And I'll put in my chain ID, that is 42. This is DevNet. And I use my node URL, which is the one under my config. The node URL is this fullnode.devnet.aptos.labs. My account will be my account address. So as we can see, the module is loaded. This new coin module has 5 entry functions, 2 resources, and 2 events. Let's look at what they are. There's function burn that destroys the coin, and there's function initialize, which initializes the module. And there's function mint, we can mint assets. And there's function register. Register is for user to receive this custom coin, and there's transfer. And this is the MetaMask in Move. It's called Potent. And I can use this to interact with it, same just like MetaMask. So every transaction I need to sign. So let's just have a look. I will unlock my wallet. And I need to import my account because this is a new account called a deployer. So I use my private key to import it into this web wallet. So I say import account, and I copy paste my private key. So this account is imported. Now I can initialize this new coin value. Let's see what they are. So initialize function is the first parameter is the address signer, which should be the owner. In this case, our sender address. And the first name string is the name of the coin, and symbol is a symbol of the coin, and decimal is the decimals that this coin has and the total supply. So you can either interact with using a key, or you can interact with the graphic interface. In this case, I'll interact with the graphic interface. I will make a coin called Dogecoin, because why not? And the symbol will be dog. And this this decimal I will put 8, and the market cap I'll put in 1 million. So as you can see, I can actually confirm this transaction just like Ethereum MetaMask. So after I click confirm, the transaction gets included. And we can see in the blockchain explorer, this transaction is indeed included. So transaction action is initialized. We can also mint and burn coin through this graphic interface. So if I want to mint to my own address or to some other address, I can invoke this mint function and the number that we want to mint. In this example, I will just mint to myself. I will mint 500 to myself. And let's see if we receive 500. Well, it failed. Let's see why it failed. First, let's check the balance, the resource that we have. Yeah, so the coin info is actually transferred to our account, but we don't have any balance right now.
You need to register.
Oh, yes. Yes, you're correct. So let's first register. Cool. And the windows here. So it's registered successfully. Let's do it again. Here we mint another 500 to our account and see if this time it goes through. Yeah, seems like it minted successfully. Let's look at the resource. So now we have another new resource called coin store. And when we click show more, it shows that the coin has value of 500. That means we own 500 new coin. Okay. That's the end of this simple tutorial. Let's continue. So there are two ways to interact with contracts on chain: module and script. Modules, same as smart contract, you need to deploy modules on the blockchain before you can use modules to interact with the target contract. Scripts are an easy way for developers to interact with on-chain contracts. You can just write scripts locally and you perform a bunch of actions that you define. Modules are similar to class. And resource is like object. So we are comparing move elements with a traditional programming language. And modules are stored in the global storage itself. Scripts are like executable entry points. They can call functions of published modules to update the global store. Scripts are temporary code snippets that are not published to the global store. It's like function main. So like we demonstrated before, we first compile the module, and then we publish it. And then we can, instead of the graphic user interface like last time, it's more convenient for developers to invoke functions in command line. And this is the way to interact with on-chain program using module. We coded a module, we publish it, and then we invoked function in our published module. In this case, our address is 0, dead beef, and the module is soft, and we invoke the function exp onto our soft module. So this module is published on-chain. And here's a way to invoke, to interact with programs using script. Here, we can see the keyword is different. It was before it was module, and now it's script. Script is also saved as a move file, and when you use Apto's move compile, it will be saved to the build directory, and under the build and your project name, and under the bytecode scripts directory, and the script name .mv. It's the move bytecode. So this is not published to the blockchain. It's saved locally in your directory. And you can use Apto's move run script, and then give it the script path. The script will be run, and you can interact with with on-chain programs that way. So this module and this script function in the exact same way, but one is deployed on-chain, another one is stored locally. Yeah.
Before you continue, can I check? So in the example that you did just now, so you created the coin, and then you created the module. So is the module like a holder for the blockchain? But I understand you did all of this in the DevNet, so does it mean it sits locally in your machine? No blocks were actually published to the chain. Or did you actually publish it? I
published on-chain because DevNet is actually, they are DevNet node. So DevNet is almost like a replica of mainnet.
Okay.
So it's
an actual chain.
Yeah, it's actual chain.
And with your coin, I'm assuming it has no monetary value,
Yeah.
right? But how come when you created a transaction, there were gas fees? So how is that fee calculated if it's zero value?
So basically in testnet or DevNet, you can get free coins from Faucet. And it's trying to imitate the real environment as much as possible.
Yeah.
So in real blockchain, you need to pay gas for transaction, right? Same in DevNet, you need to pay gas. Although you can get coins for free, but still it's just a form of resemblance.
Okay, so it's
Yeah.
just to test the functionality, the feature.
Yeah.
So what happens if you promote that test coin into mainnet? Does it become real then? Does it have monetary value?
So if you're trying to sell your testnet coins,
Yeah.
Every wallet, I think, will warn you that this network is not the mainnet network. So people will be warned.
Yeah.
But developers usually develop and deploy their contracts in testnet or devnet first before they develop in mainnet.
Okay.
This is for security purpose because if you develop in testnet or devnet, it's not going to cost you any economic damage if there's a bug,
Yeah.
and you can interact with freely. Like you can do a lot of maintaining, you can try to do different testing. Yeah. Also, we use devnet for some other, for example, like coding games like CTFs.
Yeah.
Yeah.
So if hackers develop their own coins in DevNet or testnet and promote them, theoretically they could mint their own coins, and if they get buyers on the actual mainnet,
Yeah.
does it mean that that coin is now has economic value?
It can't because in DevNet and mainnet, even you have the same address, it's separate chain. So if you deploy a test coin in the testnet, in mainnet, this address is empty. So unless the hacker, which in this case will not serve him any benefit, he can deploy the same code in the mainnet. Then the mainnet will have content. His address will have package content. Yeah.
Do you need gas to operate the script as well?
you need gas to perform transaction, right? To perform an on-chain transaction. For modules, you need gas to deploy this contract on-chain and gas to interact with your target address 2 times. But for script, you only need gas when you interact with the on-chain program, so just once. But every transaction on the blockchain needs gas. Any other questions? So let's look at blockchains that are based in Move. Here we can see a simple comparison of different blockchains. We got Aptos, we got Ethereum, we got Avalanche, which is another EVM chain. We got Solana, we got Binance, BSC, and Sui. We can see the difference of TPS. Move is superior in my opinion because it allows parallel execution and it's really fast. So the Ethereum TPS is only 30, but for Aptos it's 160,000, and for Sui it's infinite because Sui is object-oriented and object can have different parallel execution infinitely. And for time to finality, Ethereum takes almost 78 seconds to finalize a transaction, but Move chains takes less than 1 second to finalize. Well, the current TPS is not noted here, so we'll wait until Sui develop their mainnet. So Aptos is address-centric and it records the ledger as a blockchain. And it's a little bit similar to Ethereum and other blockchains. So for example, the transactions will be included in the block. And for example, in one of the block, Alice will have one few USDC and Bob will have 1 more USDC, which is a basic transfer function. And it's recorded in the ledger. So more Aptos. In Aptos or core Move, Aptos is similar to core Move. Any object with the key ability can be stored at an account, and we don't need a UID for it. An Aptos smart contract can access object of types that it defines under any account at any point in its execution, even if the caller is not the account that is accessed. This is typical done through borrow global, borrowing a reference to an object type it defines. So Aptos smart contract can access the object that it defines in the module. And it can use this borrow global operator to borrow the resource. And this is Sui. As we can see, it's quite different from Aptos. And it basically does not look like a blockchain ledger anymore. So instead of address-centric, it is object-centric. So now we are focusing on that 1 USDC right now. Sui implemented by using a structure called directory acyclic graph, DAG. So at first, this USDC is owned by Alice. And after transaction, 0.5 USDC will be transferred to Bob. So to put it simply, the 0.5 USDC changes its owner from Alice to Bob, and we are focusing on the USDC right now. Therefore, Sui has fewer operators than Aptos. There's no move to, there's no move from, and there's no acquires in Sui anymore. We are just passing objects at runtime, and no external references can be borrowed during execution. To store objects, you use the transfer on the transfer module to transfer the object to the address. So for this part, do you have any questions?
For SUI, does it mean it no longer tracks the history of ownership for a particular currency? Because it loses that chain, right? There's no chain anymore.
There's no ledger. There's no like this
there's no
ledger.
So
Yeah.
it's hard to trace back who owned that particular unit.
But you can see that the owner of USDC is actually tracked
And
appropriately.
that's saved somewhere, is it, in the chain? Is this saved?
It's saved under the USDC under the object
On the
USDC.
object,
So
okay. Does it mean that each object has its own ID and when
Yeah,
it's split,
exactly.
definitely it gets another
yeah,
ID?
yeah. So that's one of the reasons. Like it might get really bloated over time, but yeah, they're thinking of ways to fix it. Yeah, but this enables infinite parallel execution. So unlike Aptos, you still have to wait until this alias gets updated. This can just focus on the object and have parallel execution.
What happens in terms of proof of stake or confirmations? Is the confirmation applied at object level also?
Sorry?
Confirmations.
Yeah.
So for blockchain transactions, typically you need confirmations
Yeah.
to ascertain its validity.
Yeah.
In the instance of SUI, if each currency unit is an object, does it mean that the confirmations are then applied on the object itself as opposed to the block?
The block will have different like objects. Will have different object like state changes. So it's not like typical blockchain anymore. Like it records every transaction, but it focuses on the object history.
Okay, so if
Yeah.
I say 6 confirms for one USDC owner alias to be valid, so there is 6 confirms on the one USDC, so 6 confirms for each circle, right?
Yeah.
Okay, then it means it could slow down a lot because it takes time for confirmations to be collected and for consent to occur.
It can execute in parallel, and if one like state affecting changes occur, then it can still roll back. There's a consensus mechanism in that.
Okay.
Yeah, but it's the biggest innovation in SUI that it just uses object-centric model. Yeah, so we can see like different colors of circles, and they represent different objects. And we are just basically changing the owner of object. Each object has its own ledger, and transactions doesn't necessarily have to be in sequence. So all those transactions can happen at the same time. We don't need to wait for one transaction to finish before we validate other transaction.
Does it leave this open to takeover attack? Because effectively, if the longest chain wins, then the hacker could intercept and then take over the chain.
This is just like put under the object. It's one of the properties that object has. So attackers will not. It's not like different ledgers. So it's just a different object there. Okay. Yeah, the ledger is still like still SUI. Sorry.
Is it still immutable?
Yeah, it's still immutable. Yeah. And SUI objects have the key ability, since they are stored on chain, and a special first member of the struct name ID with the type UID. And they are created through this new function on the object module. And it takes the parameter of an TX context, which is a mutable reference to the current transaction context. And you can delete this object by calling delete function on the object module. So a bytecode verifier will ensure that any struct with the key ability has the special first member. That means when you define object, it must have the UID, which is essential in this model because every object is separated. Yeah. Or object states in SUI. There are different states that an object can have. It can be inside a move contract. It can be frozen and immutable. It can be shared. So if it's inside a move contract, that means it's inside the module. And if it's frozen and immutable, that means it's global read-only. But it can actually be passed by anybody. So as a developer, you need to be careful that the passing project is not frozen or immutable, because anyone can pass in this reference, and they don't need to actually have ownership of this object. And the share object is global read and write. It's the most permissive state of object. And objects can be owned by an address or owned by another object. Or object can be wrapped. In core move, the declaring contract can use types it declares from any address regardless of caller. Whereas in SUI, only the caller's own objects may be passed in. So as we mentioned in Aptos, the declaring contract can use borrow global to use types it declares from any address regardless of caller. But in SUI, you need, so every object has a clear owner, and the owner has to pass in the object themselves. SUI objects with keep and store capabilities can be freely transferred by account owners or the creating module. So it can be transferred by owner and the creating module. And we sometimes need to be careful that creating module have this power. An object with only key capability can only be transferred by the creating module. Frozen and share objects can be passed to the smart contract by anyone. So this is a comparison between Aptos and SUI in terms of a transaction context. Aptos has this special parameter called signer that indicates that who signs this transaction. The message.sender is similar to message.sender in Ethereum, solidity. So we can use this address of to get the signer's address. Address of is a function under the signer module. In SUI, there's no signer. Everything is derived from the mutable reference to the transaction context. And about transaction context, it can also be used in the initialization process. In Aptos, we use this the signer as the verification that it is indeed initiated by the owner. And in SUI, for example, the owner was derived from the transaction context. There's a sender function under the transaction context, and it will take in the parameter of the current context and output the owner address. There's a standard library. So even though Aptos and SUI both blockchains based in Move, but they have very different standard libraries. And I encourage people who are interested in security to do more research in standard library, because last year alone, there was over $5 million paid in bounty regarding the standard library issues. And when people look at standard library, they think it must be very safe, but it's not. So for example, one of the biggest hack, the BNB chain hack last year, was because of the standard library issue. It causes a loss of $100 million. Basically what happened was the precompiled library had a wrong implementation of IAVL verification, signature verification system. It copies the Cosmos SDK, and it allows the hacker to pass in fraudulent signatures and get his assets. And here is the $1 million bounty by Moonbeam. And this is also another bug in standard library in Aurora engine. So standard libraries in Move is also the same. They keep getting updated, and more contents are being added to standard library folder, and it's very important to know what things can go wrong, and maybe not included here, but also this Solana wormhole hack was also a problem of standard library. Yeah, so we can go to their GitHub page, Aptos and Sui, to check out what standard library they are using. Yeah, as we can see, Sui has significantly more standard libraries than Aptos. So it's worth taking a look at. And just getting to those details of the code will make you have a better understanding of what this chain is built for. Okay. Let's see. So, any questions? Yeah.
Can you explain why you choose to share about Move and not others like Clarity, and are they not good enough for security?
Sorry? Solana?
Why we talk about Move and not others like Clarity? Are they related to security?
For example, what are you trying to?
Clarity.
Clarity.
Yeah.
Is this a new language?
Yeah. Is it?
Sorry, because my research is focused on Rust and Move, and I think Move is currently, like, in the security industry, we think is one of the safest language. And of course, there are a lot of there are other languages like Kairos and different languages, but I haven't had time doing research in those fields. But Move is more native, as you can see. Like the assets here is really assets because you can't copy them. It's not just numbers anymore. It's actually object. It's tangible. Like you actually have one coin under your account. It's different than Solidity, and I believe other language Kairos too. It's just a mapping balance that you can just add numbers at will. So that's one of the reasons I introduced this Move, because I think it's blockchain native. So it represents the crypto assets that our mind that envisions. So for example, people used to say I have one Bitcoin and I have this one Bitcoin, like actually coin pointed out. But in Bitcoin, it's not like that. Yeah. But in Move, I think you can actually have a coin that you own. Yeah. Yeah.
Because Sui is not sequential, it doesn't need to be sequential.
Yeah.
Isn't there a potential risk when one person can promise his coins to different parties and they end up not getting what they were promised because the order will not happen? It's not sequential.
But only the transaction gets included will be final.
Yeah.
So for example, yeah.
In the time frame, they can potentially run a scam.
But we only, for example, when transaction is confirmed, we consider that as a valid transaction, right? So for example, if the attacker transfer like 0.5 to one address, 0.3 and 0.8, then the 0.8 will not go through because he does not have enough balance. And only those previous two functions will be included and get confirmed.
So I guess it's the finality timing that prevents this because it's supposed to be fast, right?
Yeah, it's very fast.
So the scan cannot
Yeah.
run. The
Yeah.
scammer cannot run.
Yeah, because the transaction gets included within 1 second, and I think everyone has the patience to wait 1 second to see the transaction gets confirmed.
Have there ever been bots that intercept within that 1 second?
Sorry?
Have there ever been bots
Yeah.
that intercept within
Yeah.
that 1 second? So it steals somebody?
Theoretically, there are. Yeah, because in reality, I think the confirmation might take longer because it's a decentralized system anyway. So there are still bots that can exist. For example, in Solana, we have bots everywhere. And even though the Solana is supposed to be very fast, like almost same TPS as Aptos, right? And there's like flash bot service in Solana. So theoretically, yes, there will be bots. Any other questions?
I mean,
Sorry?
Yeah, actual launch TPS is actually quite low.
Yes. So that's why when the system gets distributed decentralized, the TPS is not as promised. But Sui, at least it will have the same or even better TPS than Solana for sure.
Yeah, because
Yeah.
it's the same people.
Yeah. And Solana is not very stable, so all the
why
nodes
we
goes
decided
offline.
to abandon Solana to Sui.
Yeah. Also, like I don't know if you're aware of the Solana account model, because accounts are being passed by user, and as we talked before, never trust inputs from user. So you have to verify every single account is actually legit, and it takes a lot of like programming and like verification, and the code gets really bloated. And sometimes if you forgot to include one of them, you get the account impersonation attack. So and in Move, you don't have this problem anymore. So that's why I think it's superior than Solana, in that sense. It's safer. Any other questions? No questions? Then I guess, yeah, tomorrow. Tomorrow we'll continue like talking about Move and let me check the schedule and some incident analysis. So we'll take a look at some real world hacking examples and how we analyze those transactions and how our project can alert companies or project from when those incidents happen. And also we'll talk about formal verification in detail. Okay. Thank you for coming today.